All right, class, so this is an equilibrium problem, and this is a little different type of problem. In this problem, we're going to be asked to calculate the value of Kc. So, we're usually given that value of Kc, but in this problem, we're actually going to take the information in the problem that's given and then actually calculate the value of the Kc. So the first thing that I would do and sort of think about is, well, what is Kc? Kc is going to be the concentration of the products at equilibrium over the reactants, again, at equilibrium. So reading this problem, it says a quantity of 6.75 grams of SO2Cl2. So this is my initial amount of SO2Cl2 was placed in a 2-liter flask. So, I'm going to need that 2-liter flask for my molarity information to convert from moles to molarity, and allowed to come to equilibrium. Once equilibrium was established, it was found that this number of moles SO2 were present in the flask. So this is telling me sort of that information about how much is going to be there at equilibrium. And since this is an equilibrium table and I'm looking for equilibrium concentrations, I know that I'm going to need to use an ICE table, so initial concentrations, the change in concentrations, and then my equilibrium concentrations. So now I need to take this 6.75 grams and 2 liters and use that to figure out what my initial concentration of SO2Cl2 is. So if we want to do that right down here, 6.75 grams SO2Cl2 times 1 mole over 134.96 grams. So if you add up SO2Cl2, the molar mass, 134.96, and this ends up being 0.0500 moles of SO2Cl2. And then to find the molarity, I'm just going to divide that by 2 liters, right? So this is going to be my moles per liter. And for my molarity, I'm going to get 0.025 molar. So this is my initial concentration. So just using the information in the problem, this is my initial concentration of my starting material, and I'm going to write that in here. Now for SO2 and Cl2, my initial concentrations are going to be 0. And I know they're going to be 0 because basically the problem says we're just starting with SO2Cl2. So if these are 0, then that tells me that my change line is going to be minus x, and plus x. I know that this equilibrium needs to shift to the right in order to get to equilibrium because there's literally no products at the start of the reaction. So the only way I can really go is go to the right because literally you can't take 0 and go to the left, right? You've got to take whatever we have and shift that equilibrium to the right. So then at equilibrium, this is going to be 0.025 minus x, and x. Now we are told what this value of x is. And we're told what this value of x is sort of indirectly by being told what the number of moles of SO2 is. So if I convert that moles of SO2, 0.0345 moles of SO2 over 2 liters, I know that my concentration of SO2 at equilibrium is 0.01725. So if you do this calculation, you end up with a molarity of SO2, all right, at equilibrium of 0.01725. This is equal to your x value, right? At equilibrium, this x value is going to be the concentration, right? These are molarities, the concentration of SO2 at equilibrium. So this is equal to your x value, and that's a really key bit of information. So now we have all the information we need in order to solve for our actual Kc value. So the way that I'm going to do that is, first, we might like to write out what my concentrations of everything are. So SO2, we know, is 0.01725. And by extension, that's going to equal also my concentration of Cl2, 0.01725. So those should be the same, right? It's a 1-to-1 mole-to-mole ratio. So there you see the 1-to-1 mole-to-mole ratio, x value, that's my concentration. And then for my concentration of SO2Cl2, my starting material, it's going to be 0.025 minus that x value. So we need to make sure we take that into account. And so my concentration of SO2Cl2, that's going to equal 0.00775 molar, right? So I'm just taking 0.025, subtracting this x value right here. So subtracting this x value and I end up with 0.00775. So then lastly, I can solve for that actual Kc value. I'm going to take my concentrations of my products, 0.01725, 0.01725, divided by 0.00775, and I calculate this as 0.0384. Now, the last bit step for this would be to think about the units for this. So since in my KC I've got molarity times molarity divided by molarity, so sort of one way to think about it is that those molarities will cancel. I'll be left with units just of molarity. So this is my final answer here.